Hello developers, welcome to Top Trending Open Source GitHub Projects. This week, Part 1, we are diving into 10 cutting-edge tools that redefine how we code, collaborate, and ensure privacy. Today, we'll break down the production-grade visual compression of DeepSeek-OCR, the ethical, non-invasive design of the Helium web browser, and the structured, rule-based conversational AI of Parlant. We'll also cover API testing with the multi-protocol capabilities of Hoppscotch and seamless multi-computer control using Deskflow. Stick around as we walk through each project step by step to upgrade your toolkit.
Welcome back to Manu AGI Tutorials. Here, we explore the exciting world of AI, latest AI tools for you, so don't forget to hit that subscribe button and the notification bell so you don't miss out on the latest AI insights. So let's start today's video.
Project number 1. DeepSeek-OCR, a cutting-edge OCR model that radically rethinks how text is captured from visuals. What makes this project truly unique is how it approaches OCR not just as reading text from an image, but as compressing vast textual contexts via visual encoding to make long context processing efficient. Rather than treating images of pages merely as sources of text lines, the model transforms them into an optimized vision token form so that downstream models consume far fewer tokens while still retaining the meaning. One standout feature is its compression ratio. When the number of text tokens is within 10 cars that of vision tokens, the accuracy of decoding remains around 97%. Even when pushed to about 20 tokens, it still achieves roughly 60% accuracy. This is unprecedented for OCR-type systems that also aim at long context tasks. So the model isn't just about extracting text visibility-wise, but optimizing how much information the rest of an AI pipeline must process. Another part of its uniqueness lies in the practical throughput. On a single A100 GPU 40G, it reportedly can process over 200K pages per day. That scale means this is more than a research demo. It's positioned as a production-grade tool for massive document pipelines. The architecture also stands out because it pairs a deep encoder that transforms high-resolution inputs into efficient embeddings, and a DeepSeek 3B MoE A570M decoder that handles the interpretation of those vision tokens. This two-stage design is optimized for large-scale OCR of diverse layouts, charts, tables, and even complex page formats, rather than just plain scanned text. But perhaps most critically, the project shifts the mindset. Instead of thinking how to extract text from an image, it asks how to transform visual document contexts into digestible tokens for large models. This shift enables combining OCR, layout understanding, and long document context handling all in one system, a major leap beyond classic OCR. In short, this tool stands out because it bridges high-throughput image-to-text conversion, extreme context compression, and scalable document-level understanding, offering a new way to integrate visual text into AI workflows at scale. Project number 2, Helium, private, fast, and honest web browser. What makes Helium truly unique is its foundational commitment to privacy and minimalism. Unlike mainstream browsers that come packed with trackers, pre-installed extensions, and vendor lock-ins, this tool is essentially a cleaned-up version of the Chromium engine, meticulously stripped of Google's telemetry, background services, and bloat, and repackaged under an open-source ethic. Where many alternatives still lean on proprietary modules or tie-ins to large ad networks, Helium takes an explicit stance: the browser is for us, and non-invasive by design. This means when you open it, you're given a platform that respects your data and presence, rather than treating you as a commodity. In other words, Helium is not just about speed, but about trust. Another standout point is the cross-platform ambition. Though currently the most polished build is for macOS, the project has active packaging efforts for Linux and Windows, showing that the privacy-first browser movement isn't being limited to a single OS ecosystem. The open-source nature means you can inspect, modify, or just trust that nothing hidden is happening behind the scenes. Performance and ethics go hand in hand here. Because much of the Google-specific subsystems are removed, the engine runs leaner and starts from a more transparent baseline. This gives users who care about both responsiveness and privacy a rare dual benefit: a familiar browser interface with an unfamiliar dedication to integrity. Finally, the project's stated philosophy sets the tone. We don't intend to reinvent the wheel. The main goal is to provide an honest, comfortable, privacy-respecting, and non-invasive experience. That's what elevates Helium from just another Chromium fork to a conscious choice for users who value sovereignty over their web environment. All told, Helium's uniqueness lies in its clear refusal to play by the usual browser rules. It asks not how many features can we add, but how much can we remove while still delivering the full web experience, and by doing so, it gives users something rarer than mere speed, a browser rooted in ethics. Project number 3, Blind Watermark. Blind and invisible image watermarking. What makes this tool truly stand out is its clever ability to embed a watermark into an image in such a way that the watermark is practically undetectable, and importantly, it can be extracted later without the need for the original unwatermarked image. That combination of invisibility plus blind extraction is rare in watermarking solutions. This tool uses advanced image processing techniques to hide information in an image based on transformations, such as DWT, DCT, CFD, so that the watermark survives typical attacks like cropping, resizing, brightness changes, noise, and even partial masking, and still can be retrieved accurately. Because the watermark is embedded in a robust way, the image remains visually unchanged to the human eye while carrying hidden data that can be pulled out later even if the original image is lost or altered. Another aspect that makes it unique is its resilience against modification design. Whether the image is rotated, cropped, masked, or brightness altered, the watermark extraction process still works with high reliability. That means it doesn't just embed data, it embeds data smartly. Also, the tool is built to be developer-friendly and production-ready. It supports batch processing, parallelization, using multiple processes for embedding extracting, and is documented with examples of different attack scenarios and how it survives them. For creators or photographers who need to protect intellectual property, or apps that need to track image ownership or provenance, this kind of watermarking offers a strong technical foundation. In short, what makes Blind Watermark special is the combination of invisibility, extraction without original, robustness against real-world image tampering, and ease of use. It's a tool that elevates image watermarking from a basic overlay to a serious, stealthy protection layer, one that fits into modern workflows where images get shared, modified, compressed, and still must retain their hidden metadata. Project number 4, Hoppscotch, Open Source API Development Ecosystem. What makes Hoppscotch unique is how it transforms the often clunky task of API testing into something streamlined, intuitive, and fully open source. Unlike many traditional API clients that feel heavy or locked behind closed systems, Hoppscotch presents a minimalistic interface built for speed and clarity. Its lightweight design ensures you can send requests, view responses, and iterate in seconds. Another distinguishing factor is its rich set of supported protocols. Not just standard HTTP methods, but WebSocket, GraphQL, MQTT, and server-sent events, making it incredibly versatile for modern web developers working across REST, real-time streams, and IoT scenarios. This breadth means you don't have to switch tools or add extensions when your backend stack evolves. Hoppscotch adapts instead. Collaboration and sync are built into its core. Workspaces, collections of requests, environment variables. All of these can be synced across devices and teams, so whether you're solo debugging an endpoint or collaborating across a dev team, everyone stays in the loop. It also features cloud local session storage and shareable links for public APIs, which makes it ideal for demoing or troubleshooting on the fly. It also shines in developer experience. You'll find theming options, PWA support, keyboard shortcuts, and a smooth UI that stays out of the way. For example, you can install it on your desktop, run it offline, and even customize accent colors, toggle Zen mode, and keep your focus on the workflow rather than fighting the tool. Finally, the fact that it's open source under the MIT license and boasts a vibrant community with tens of thousands of stars gives it credibility and future-proofing that many proprietary clients lack. You're not just using a tool, you're joining an ecosystem where you can contribute, customize, and adapt as your API toolbox evolves. In short, what makes Hoppscotch stand out is how it blends speed, versatility, collaboration, and openness into one elegant interface. For developers who want to explore, test, and collaborate on APIs without the overhead, this tool brings the right mix of simplicity and power. Project number 5, Parlant, Predictable, Rule-Based Conversational AI for Real-World Deployment. What makes Parlant truly stand out is its focus on turning conversational agents from unpredictable chatbots into behavior-guided systems that consistently follow your business rules. Rather than relying on hope that a large language model will stick to instructions, it offers a framework where journeys, guidelines, canned responses, and tool use are first-class concepts designed to enforce behavior. The idea of journeys is one of the core unique features. With Parlant, you can define a sequence of states or steps, for example, a customer wanting to refund, or a user scheduling an appointment, and map how the agent should respond at each stage. This means your agent isn't wandering freely through conversation space, but following a structured flow. At the same time, it stays flexible. The agent can skip states or jump ahead depending on context, so you get structure without rigidity. Another standout is the concept of canned responses and behavior guidelines. Rather than leaving the model to generate everything from scratch, which opens the door to hallucinations or tone drift, you craft response templates and rules about how the agent should act. The framework then enforces those rules, mapping conditions to actions, ensuring consistency in tone and behavior. For domains like financial services, healthcare, or legal tech, where compliance, accuracy, and predictability matter, this behavioral control is a game changer. Tool integration is another pillar of what makes Parlant unique. You don't just chat, you connect to external services, fetch data, trigger workflows, and embed that into agent behavior. That means the agent can act, not just talk. Explainability is also built in. You gain insights into why a guideline was matched, which rule triggered which response, and you can inspect the decision path. That level of traceability is rare in agent frameworks, and it makes it much more viable in production. In short, what distinguishes Parlant is that it treats conversational AI not as a free-form chat engine, but as a behavior-controlled agent platform designed for real user-facing scenarios where reliability, structure, and compliance matter. It's that shift from just generative to guided and accountable that gives it its uniqueness. Project number 6, Paperless-ngx, Next-Gen Document Management for the Modern Age. What makes this tool genuinely unique is how it reimagines document management by placing searchability, automation, and privacy front and center. Instead of files buried in folders and PDFs scattered across disks, this system transforms every input, whether scanned image, office file, or email, into a fully indexed, searchable digital asset in your own archive. At its core, the tool uses built-in OCR, optical character recognition on any image document in more than 100 languages, so even purely photographic scans become text you can find, filter, and reuse. That alone changes the game. Your paper pile becomes a database you can query. Then layer on the intelligent automation and machine learning-based matching that automatically tags documents, assigns types or correspondence based on patterns in previous uploads. The platform also shines in how it integrates into real-world workflows. You can drag and drop uploads, let the system monitor email inboxes, apply custom fields, filter by tags and correspondence, and share links with expiration. From a user's perspective, the UI feels modern and intuitive. No archaic file manager or hidden menus. Everything is built around discovery, not just storage. Another standout is data control and integrity. Your documents remain stored locally, if you choose, and the system supports long-term archiving formats, structured metadata, and workflow systems. This means you're not locked into cloud silos. You can run the system on your own server, keep your data, and keep your privacy. Finally, the community-driven nature of the project also adds to its uniqueness. As a successor to earlier projects, it's actively maintained, well-documented, and backed by a strong open-source community. Altogether, what stands out is not just the features, but how this tool redefines what a document management system can be: searchable, smart, automatic, and under your control. Project number 7. OM1, creating highly capable, upgradable AI agents for physical and digital worlds. What makes OM1 stand out is its ambition to treat AI agents not as isolated software modules, but as full-fledged autonomous entities capable of perception, action, and adaptability across a broad range of platforms. Unlike frameworks that focus purely on digital agents or single-domain robotics, OM1 is built with a modular architecture that invites sensors, actuators, language models, and robot hardware to all plug into one unified runtime. This means you get one system that can handle data from cameras, LiDAR, even web/social inputs, and translate that into motion, speech, or navigation behaviors in real robots. The modular design is a major differentiator. You can swap in new input types, change hardware abstractions, or update the agent behavior without rewiring the entire system. Because OM1 treats the agent logic, sensor adapters, and hardware connectors as distinct components, it gives developers freedom to build for a humanoid, a quadruped, or even an app with minimal friction. Another distinctive aspect is its support for real-world robotics alongside digital simulation. Many agent frameworks stop at virtual environments. OM1 is designed to engage with actual robotic stacks, like ROS2, Zeno, Cyclone DDS, and run on platforms ranging from large-scale compute to embedded devices. Another unique strength is how OM1 brings multimodal capabilities into one pipeline: visual, auditory, and language inputs all feed into a unified agent that understands and acts. The ability to take a camera feed, infer context via a language model, then trigger a movement or speech action, this integrated workflow is rare in open-source robotics. On top of that, the configuration files allow new behaviors and combinations of sensors' actions without touching the core system, making the system extensible and upgradable as robot capabilities evolve. Finally, OM1's ambition to be used across digital environments and physical robots gives it a broad applicability, from educational robots to industrial humanoids or app-based agents. The fact that this tool is open source under MIT and is designed to let you plug in new hardware or models makes it not just a narrow robotics library, but a general-purpose agent runtime built for the next generation of intelligent machines. Project number 8, WebMCP, extending the web for AI agents. What makes WebMCP truly unique is how it brings together web applications, AI agents, and users in the same context, turning static sites into tools that agents understand and act upon. Instead of just exposing APIs on the back end for agents to call, WebMCP allows the web page itself, via its client-side logic, to declare tools, functions with natural language descriptions and structured schemas that agents, browser assistants, and accessibility technologies can invoke. This means a developer can take the existing interactivity of their front end and open it to collaboration between human and agent with minimal friction. The page registers meaningful tools, the agent invokes them on behalf of the user, and the user and agent share the same UI context. That cooperative workflow, rather than the agent simply acting in isolation, is what gives WebMCP its standout character. Another unique dimension is how WebMCP focuses on shared context, rather than just tool invocation. The agent doesn't just call a backend, it works in the same interface as the user, sees the same page state, and the user retains full control, reviewing, modifying, accepting or rejecting the agent's actions. That human-in-the-loop design acknowledges that agents are collaborators, not replacements. WebMCP also lowers the developer burden. Traditional agent integrations often require back-end services, REST APIs, separate endpoints, and complex schema definitions. WebMCP repurposes the front-end logic you already have, allowing you to mark up or register the tools in client-side JavaScript, so you don't have to rebuild your site architecture to support agent interaction. Finally, the inclusivity and accessibility use cases elevate WebMCP's significance. Project number 9, Deskflow. Share a single keyboard and mouse across many computers. What truly sets Deskflow apart is its ability to let you use one keyboard and mouse to control several computers, as if they were one workspace, without the hassle of extra hardware or complicated setup. Instead of swapping between devices or buying expensive switchers, you move your cursor across screen boundaries, and your inputs follow you, offering a fluid, unified experience. Another standout feature is its multi-platform and network-friendly design. Whether you're working on Windows, macOS, Linux, or even FreeBSD systems, Deskflow supports a wide range of operating systems. Plus, it talks over the network, so all connected machines behave like extensions of your main setup. That means less context switching and more seamless productivity when your workflow spans multiple machines. Security and modern display support also contribute to what makes this tool unique. With TLS encryption turned on by default, your keyboard and mouse inputs are safe even when passing over the network. On Linux, support for Wayland, the modern display server protocol, means it stays current with the latest in desktop infrastructure. Another key benefit is its clipboard sharing and convenience features. Deskflow doesn't just let you move your pointer across machines, it shares the clipboard too. So you can copy on one machine and paste on another instantly, which dramatically simplifies workflows that span devices. Finally, the open-source nature of Deskflow means it's community-driven, transparent, and free. It's not locked into a commercial product with hidden costs or arbitrary limitations. With wide platform support, active contributions, and an open license, it offers flexibility and trust to the developer or power user who wants full control. In short, this project stands out because it removes the friction of working across multiple systems. One keyboard, one mouse, many machines, zero hassle, and it does so with security, platform breadth, and open community behind it. Project number 10, Rybbit, a modern alternative to traditional tracking with full control and simplicity. What makes this tool uniquely powerful is the way it reimagines analytics from the ground up, putting privacy, clarity, and control front and center. With Rybbit, you're not simply adding another dashboard, you're adopting a platform that strips away the baggage and complexity of many legacy analytics solutions. From day one, it emphasizes intuitive insight, Page views, bounce rates, session durations, all delivered in an interface designed to make sense rather than overwhelm. One standout trait is its commitment to privacy by default. There's no reliance on cookies, no invasive user tracking, and full compatibility with laws such as GDPR and CCPA. That means you can deliver analytics without alienating users or risking regulatory headaches. For any creator or company wanting to stay ethical and compliant, this is a major differentiator. Another aspect where this platform shines is in its product analytics depth. It doesn't stop at tallying page hits. You get session replays, user journeys, funnels, goals, and retention analysis all built in. You can see not just that users visited, but what they did, how they moved through your site or app, where they dropped off, and so use that to tune experience and increase actual impact. Then there's accessibility and deployment flexibility. Whether you want to spin it up in minutes via a hosted version or self-host on your own server for ultimate control, this is supported out of the box. And because it's open source under a strong license, you're not locked in. You're empowered to adapt. Finally, the overall mindset of the project emphasizes usable insight over noise. Too many analytics tools overwhelm with data. This one aims to clarify. It's designed so teams of any size, from solo creators to growing startups, can get meaningful usage patterns, actionable metrics, and product improvement levers without needing a full-time data science team. In summary, what makes Rybbit unique is this blend of privacy-centric architecture, product-level depth of analytics, deployment flexibility, and clarity of insight, all wrapped in an open-source project you can trust, control, and grow with. We just walked through 10 groundbreaking open-source tools that solve crucial challenges for modern developers. Whether you need to optimize document processing using DeepSeek-OCR's context compression via visual encoding, ensure data autonomy with Paperless-ngx's searchable archive, and more. Hit that like button, subscribe for more deep dives, and let me know in the comments which of these tools you plan to integrate first.